Released free response question number 4 from the 2012 AP Calculus test, part D. It says find the value of the integral from 0 to 5 of x square root 25 minus x squared dx. Again, a very straightforward question. There's not a lot that we don't even have to explain or justify anything. We just have to find the value. But we have no calculator to do this. This is a no calculator question. I think previously I might even have said it was calculator, but it is a no calculator question. So that means I need to figure out how to do this. So the integral that I'm supposed to find is the integral from 0 to 5 of x square root 25 minus x squared dx. When we first read this question, part of our strategizing was that we think this is probably going to be a u substitution problem because I see one function that is inside another function. So this is probably going to be a u. And in fact, out here, I see something that's not exactly the derivative of that inside function, but it's related to it. The derivative would be negative 2x, and I just have x. So what I usually call that is a du in quotes. It's almost the du. It's close enough that we can play with it and make it work. So that's an almost du. Now, before I go through and actually do the u substitution, we're going to want to change the form of this. So we're going to make it the integral from 0 to 5 of, and I'm going to put the u first, 25 minus x squared, and we're going to take that square root and make it a 1/2 power. And then I'm going to put the part that I know is part of my du. That way I've got my whole du together. So now, once I am here, I'm ready to say, all right, this is u, and this is close enough to my du. So let's look and see what those things are. So we'll start by saying u is 25 minus x squared. And to find the du, what we need to do is do the derivative of 25 minus x squared. So the derivative of 25 minus x squared, of course, is negative 2x. And it's critically important that we put the dx on there. So if we lose that dx, it's going to make it difficult for us to match up the substitution. But the problem that I have is that the du that I have does not exactly match the du up here, because I just want this x dx, that's what I have up here, but I got this negative 2 sitting here. So what I do is I just divide that negative 2 out. So we're going to divide both sides by negative 2. But of course, we're not going to write du over 2. We're going to write negative 1/2 du equals x dx. Now, once I've done that, I'm ready to see that my x dx that is here matches this negative 1/2 du. This matches, and I'm going to replace it with that. So now I'm ready to do my substitution. So I can bring down my integral from 0 to 5. I can replace the u. I'm going to replace this 25 minus x squared with just u. And I'm going to keep my 1/2 power on. And then my x dx right here, since that's equal to negative 1/2 du, I'm going to call that negative 1/2 du. Now we're going to change this form around a little bit, but I want to point out that some people do this integral differently than I do. I keep the limits the same, and then at the end, we're going to substitute our 25 minus x squared back in. But we're going to see that an alternative way to do that, and many people do it this way, is instead of keeping the limits 0 and 5, they'll take the 0, put it into this function and say 25 minus 0 is 25 and put that for their lower limit. And then they'll do the same thing with the upper limit. We'll take the 5 and put in 25 minus 25 is 0. So they'll have their integral from 25 to 0. That's called change of limits. And that's a matter of a style choice. I have a little bit of inconsistency in my integral here because the limits are limits on the variable x, but my integral is in terms of u. So I have a little bit of a conflict there, but I'm going to resolve the conflict in the end so it doesn't bother me much. Now, the next thing I need to do is take a constant like negative 1/2, and I'm going to factor that out to the front. So now I have negative 1/2, integral 0 to 5 of u to the 1/2 du. Now once I'm here, I'm ready to actually do the integral. When I do the integral, I'm going to take my exponent, I'm going to add 1 to it and divide by the new exponent. And when I do that, since it's a definite integral, I'm going to make a nice big evaluation bracket. Since it's a definite integral, I'm going to put on the limits, but there's no plus c. And I'm going to raise my exponent 1, so 1 plus 1/2 is 3/2, and divide by the new exponent, which is 3/2, and don't lose your negative 1/2, which is in front. That's going to stay there. Now, the next thing that most people would do with this, and some people even just do this step immediately, we don't like this fraction, this compound fraction. We don't like this fraction down here. So we're going to flip that fraction over and bring it out. So I'm going to have my negative 1/2. That's a funny looking 1/2. There we go, negative 1/2. I'm going to flip that 3/2 over and make it 2/3. And then now I no longer have this fraction in here, so I have u to the 3/2 power, evaluated from x equals 0 to x equals 5. And then before I even start doing this, I'm going to simplify this fraction out here, maybe at the same time. So we can reduce these 2's. Don't lose that negative, so we have negative 1/3. Let's go ahead and substitute back the u. Our u is 25 minus x squared, so in place of that u, we're going to put our 25 minus x squared back in there. But that 25 minus x squared is raised to the 3/2 power. And then I have from 0 to 5. Now my job is to plug in the 5, plug in the 0, and subtract. So this is equal to negative 1/3. This is using the second part of the fundamental theorem of calculus. First I'm going to put in the 5. So we'll put that in there. And we're going to get 25 minus 5 squared to the 3/2 power. And then I have a minus from the fundamental theorem. And then I'm going to plug in the 0. And plugging in the 0, I get 25 minus 0 squared to the 3/2. And you can probably see a couple of ways I could shorten this up by saying, well, I know this one's 0. I know this one's just 25. Also, once we've replaced the limits in the value for x, in terms of our AP scoring, we're done right there. Don't do anything else. Because you could easily make a mistake working the rest of this out, so you don't want to do that. So you want to leave it here. No, I can't resist. We have to simplify it out. Also, we're going to need that for the scoring anyway, but you're going to leave it there on your AP exam. So let's see, 25 minus 5 squared is 0, so that's 0. 25 minus 0 squared is 25, so I have 25 to the 3/2 power. And so I'm going to bring my negative 1/3 over. So 25 to the 3/2 power means I'm going to take the square root of 25 and then cube it. The square root of 25 is 5, and 5 to the 3rd power is 125. So this is negative 125. And my final result is 125/3. This is what your calculus professor is going to want to see when you get to the university as your final answer. But this is what you want to leave on your AP exam so you don't A, waste time, and B, accidentally make a mistake. And now we're done with part 4, so we can do the scoring.